One. Right, there's a problem giving a seminar about him. Almost nothing is known. There is a particularly interesting paper which has been lost. We don't know what the title was, and we know almost nothing about the content. So we'll come to that. There is a couple of books. The main one is by Thomas Heath. It looks fairly solid, but actually he's filled it up with 22 other Greek philosophers before he gets to Aristarchus in the back of the book. Right, apologies for my pronunciation of Greek. I see Grant was also a little challenged by it. There's a few more that challenged me. So we'll have a look at the status of ancient Greek astronomy. We'll have a look at Aristarchus of Samos. Samos is rather a nice Greek island, just off the coast of Turkey. We'll look at the methods from a document on the sizes and distances of the Sun, Earth and Moon. We'll have a look at Eratosthenes of Cyrene, who also comes into the story. Then we'll have a look at the lost document and summary, and finally some scale diagrams. Right, the ancient Greek astronomers didn't have many advantages. So they had none of the tools, no telescopes. It was about almost 2,000 years later. No accurate clocks, no precise measurements. Serious problems with mathematics. So arithmetic was limited to integers and ratios of integers. No algebra, trigonometry or calculus. There was geometry, so Euclid geometry existed at the time. No standard measurement units. Have a look at the problem that comes out. Basically, only naked eyesight, rulers, protractors, possibly a water clock. Right, the universe was generally thought to be centered around the Earth. Here's a diagram. It's actually from the Middle Ages, that one. With the Sun in the center. No, the Earth in the center, sorry. We've got the Earth, and then the Sun is somewhere out here. And the stars are typically little bits of glass stuck on the edge of the firmament. There's also the Greek version. They had to have somewhere for the gods to live, so they have a central fire in the middle. The Earth goes around that, the Sun goes around that. The counter-Earth I haven't discovered quite where that is. It seems to be the rest of the gods in the underworld live there. And again, the stars are stuck on the edge of the firmament. Right, earlier observations. Quite early it was realised the Moon was actually lit by the Sun. The Moon was spherical. The Earth was spherical from evidence of lunar eclipse, which they'd recognised it was a shadow of the Earth on the Moon. Ship scope vanishing over the horizon, and the different stars you could see from different locations. So they were quite happy that the Earth was round. Not everybody believed this for thousands of years afterwards. The morning star and the evening star were eventually recognised as being the same planet, possibly by Pythagoras. The astronomical records mostly have been lost, only a few references to lost books, second or third hand reports, not always consistent. Where records exist, it's a bit of a challenge to work out what they mean. we'll come across measuring angles in terms of zodiacs. And most of this material was stored in the Library of Alexandria, of which I've got a picture. I have no idea how I got that picture. The Library of Alexandria was reported to have 500,000 scrolls. It has all vanished. They don't even know where the foundations are. It's thought they might be in the middle of the harbour of Alexandria now. And the scrolls have all vanished. So all the Arab Greek knowledge was apparently burnt heating bathwater in the local brothel. Right, a quote from Vitruvius, 1st century, and here we see Aristarchus of Samos gets prime mention. So he had a reputation at that time, which carried on with him as being one of the top people there, and Eratosthenes also gets mentioned. So he was known, but as we saw, not many people know of him these days. Right, he was also known as Aristarchus the Mathematician. So this is from another book here. Gomez would like to promote his book. So you read that. So he made some extraordinary advances that were largely forgotten and largely lost. There is a statue of him in a Greek university, which indicates you had to be a certain amount of importance to get a statue. He has a crater on the moon also. That crater has more conspiracy theories about it than any other crater on the moon. It's actually the brightest spot on the moon, and that's where all the flying saucers come from. So one of his documents still exists. Copies differ slightly. It's titled On the Sizes and Distances of the Sun and the Moon. So you can think how, by simply looking at the sky, you can determine the size of the sun, moon, and distances of the sun and the moon. Few people have done that. It's presented as an interesting calculation, possibly to avoid problems, which he did run into some. It is purely geometry. It's set up as a Greek geometrical problem. The results are given as ratios of integers. We'll have a look at them in a moment. And it does not make any claims on the nature of the solar system. It does imply the moon goes round the Earth. Right, so what's known about him? The dates are a pure invention of when he lived. He was known to be alive 280 BC. Those two dates on the top were actually invented by Sir Thomas Heath in this book. He developed a hemispherical sundial. None of them, there's no example that exists. There's no description of what it was like, but if you have a hemisphere and told to build a sundial, there aren't many options. And having built it, it does give a good indication of how the sun is moving across the sky, because the ball gives you an inversion of the sky. It is rumoured to give months as well as time. Improve the accuracy of the year, supposedly, and a thing called a great year, which is when all the planets come back to where they were when you started. He develops mathematics needed for small angle triangles and has an inequality which is not greatly known, but he needed the information on small angle triangles for his calculations. The manuscript, the sizes and distances, survived from a copy in the Vatican, which was made in the 10th century by a nun who copied quite a lot of Greek literature and stored it in the Vatican Library. Quite a lot of material survived there. And it seems that all the Greek copies are copies of that particular document. There are also a couple of Arabic copies, and exactly where they came from, nobody seems to know. One of them does have an extra paragraph in, which is not in the Greek copies. Not a very exciting paragraph. Right, and there's a paragraph in Archimedes' Sand Reckoner, which we'll come to, which gives some information. Right, on the document, it gives geometrical arguments in the manner of Euclid. It starts off hypothesis. The moon receives its light from the sun. The Earth is in relation to a point at the centre of the sphere at which the moon moves. And there are 6 of them. The last one being the moon subtends 1/50th part of a sign of the zodiac. That's a particularly interesting one. There's 12 signs of the zodiac, so this is the angular size of the moon. Seriously wrong. Which, strangely enough, didn't have a great effect on his calculations. And Euclid, in the Sand Reckoner, has a little note that Aristarchus knew that the size of the moon was 1/50th of a zodiac, not 1/15th. And 1/50th is about right. So the results from this, the diameter of the sun has to the diameter of the Earth a ratio that is greater than 19 to 3, but less than 43 to 6. So fractions hadn't been invented, and in particular decimal notation hadn't been invented, which is a serious difficulty to doing calculations. And the diameter of the moon is less than 2/46, but greater than 1/60th of the distance of the moon. So he'd gone outside and looked at the sky and managed to determine these ratios. He actually only determines ratios rather than actual values. So how did he do this? Right, distance to the sun, a couple of pieces of information. Eclipse of the sun. I don't know how many people lost their sight looking at this. But it shows that the sun is further away than the moon. and they have very close to the same apparent diameter. And viewed from the Earth, the half moon faces the Sun, and if the Sun's fairly close, this is not quite on the half of the orbit. So this distance in time converts to an angle, and the small distance up the top here means the Sun is more distant, and if the time is larger, giving you a larger angle, the Sun is closer. So you can go out and watch the moon and determine when it is at a half moon and see how much different it is. He did this and he got the difference of 6 hours, which gives 3 degrees, and that gives the Sun 19 times further than the moon and also 19 times larger. So putting the Sun rather large, the general theory was that the Sun was about the size of one of the smaller Greek islands, possibly a mirror on the central fire. So that is his first piece of information. Here is his guy. He had to calculate the sine of 3 degrees, or 1 over sine of 3 degrees. No tables of sine angles, no calculators of course, not even any decimal notation to write out tables. So here is his geometric calculation. We have the checklist. We have the Earth here, the moon over next to it, and the Sun up here, and that is his construction to work out the sine of 3 degrees. It takes him about 5 pages of calculation to work through this. So without a little bit of trigonometry and more modern mathematics, it becomes a very tedious calculation, which no doubt was why he was known as the mathematician. Right, distance to the moon and the sizes of the Sun, Earth and Moon. Right, if we take a ball and put it in the Sun, we note that the shadow is of limited length. And we can assume the same geometry applies to the shadow of the Earth. So we have some pieces of information we can use. The Sun and the Moon are the same apparent size from the eclipse. The Moon during its eclipse is about half of the Earth's shadow. So if you look at the eclipse, I had a picture of the eclipse up earlier, and so this gives us the relative sizes of the Earth, Moon, Sun, Earth and Moon. And the apparent diameter gives us the ratio of size to distance. How do we do this? This is not how he did it. He did it by solely Euclidean geometry, about 20 pages more of it. Quite complicated. So we have the Sun and Moon are the same apparent size, so we can draw a couple of lines there. We move on, and the Moon over here is half of the Earth's shadow there. We can now correct our diagram. So we adjust the Earth to the right size so the shadows are right. And there we have the geometry he is using. So here we are. We know the relative distance to the Sun and Moon. and we can write out the proportions and a little bit of algebra, which was invented about 1500 years after he lived. We get the ratio of the sizes of the Earth, Sun and Moon. He actually went into some more complicated calculations. The lines touching the Earth are not exactly on the diameter, but are slightly off. So he calculated the effect this had, which was about 0, particularly regarding the accuracy of the other things which had gone into the calculation. So that calculation was really not necessary, and it turns out he was calculating the ratio, and the ratio is the same on where we have the contacts and where we don't. Here's his diagram, one of them, which he was using, and you can see there he's got his contact points of the visibility. That one's visibility on the Sun, and the difference from the diameter of the Sun. So he went through a good number of pages of that. I am not sure, but that is probably a copy of the diagram done in the Vatican in the 10th century. So, he'd assumed for his calculations 1/15th of the zodiac, that is 2 degrees. Yet it was noted by so it was noted that he actually knew that it was 1/50th, and whether he corrected the calculations or not, it is not known. He gives the distance to the Moon as 26.6 times the diameter of the Moon. He calculated between 45 to 2 and 30. So Archimedes in the Sandwreck stated that Aristarchus knew the Sun and the Moon were half a degree, 1/750th of the zodiac circle. Where this difference came from has not been resolved, but half a degree gives a reasonable estimate of the distance to the Moon. Right, the other person involved was Eratosthenes of Cyrene. His dates are reasonably accurate. He's also got a crater on the Moon. He is known as the originator of geography, of which he wrote 3 books, none of which exist. He is said to have used parallels and meridians to link together every place in the known world and create maps. He was also the chief librarian at the Library of Alexandria. He was reputed to go out every time a ship arrived to check whether they had any scrolls that he didn't have in the library. How good his memory was for the 500,000 scrolls reputed to be there, I'm not sure. Then, if he did find a scroll of interest, he would take it and copy it. No problems of copyright in those days. And it is said that his copies were indistinguishable from the originals. You may have heard the name in the Sieve Eratosthenes, which finds prime numbers, which occasionally still gets uses. And the other thing he is well known for is determining the diameter of the Earth, or more accurately actually the circumference of the Earth, which he did by noting he seemed to have a lot of information from various parts of the known world, and the information had come back: the sun is vertical at the solstice in Syria, which is about Aswan. So there's supposedly a dam there which gets sunshine to the bottom of the, well, not a dam. And he also noted in Alexandria this didn't happen, and he measured the angle. He also estimated the distance from Cyrene to Alexandria. One rumour is he sent somebody out to count the steps. This seems unlikely. And he estimated as 1,000 stadia, which seems to be a pretty round number. A stadia is the length of the stadium. When I gave this over at St Lucia last year, a couple of the classics department turned up and said that all the stadia were the same length. It turns out the track within the stadia has the same length, but the actual stadia varied in length, and we don't actually know which stadia length he was referring to. Probably doesn't matter much. It gives a quite good estimate of the Earth's diameter. In fact, if you take the right stadium, it's very good. Far more accurate than you would expect. Right. Now we come to the lost document. There's a paragraph in Archimedes' document, the Sand Rector. This is the document where Archimedes said you can count all the sand grains in the universe. We have a counting system which will stand up to this. Basically, it seemed to use Roman letters and didn't stand up to it too well. Right, so he says Aristarchus proposed a hypothesis in writing. This is the only evidence there's a document, which follows that the universe is much larger than now commonly believed. From Archimedes, he says he proposed the firmament and the sun were unmoving, and the earth described a circle around the sun, which was related to the centre of the orbit. So we have the earth going around the sun, and the sphere of the fixed stars was as great relative to the orbit of the earth as the sphere is to its centre. So he's saying that if you look at it the other way around from a star, looking at the sun, it will look like a point. Archimedes goes on to say, this is rubbish. The point at the centre of the circle is a point, it's got no dimensions. We can't have the Earth's orbit without dimensions. But it seems to be a good estimate of what the situation is, in fact. So he had the fixed stars very distant. There's a couple of other comments Archimedes added, for he adapts the proofs of a phenomena of this kind, which, looking at his previous document, it seems that he has developed geometry to show how his assumptions have been derived. There's a couple of other references in the literature. Eratosthenes Archimedes sets the sun among the fixed stars, which it depends exactly how you translate it, which is difficult, but it would seem he is saying that the sun is one of the stars. This ties up with what he was saying about the size of the universe. And the earth moves around the sun and is put in the shadow according to the earth's inclinations. And another from Eratosthenes, who lived at the same time as Aristarchus, which was only quoted by Plutarch sometime later, for putting in motion the half of the universe, supposing the heaven remains at rest and the earth revolves in an oblique circle while it rotates at the same time about its own axis. So an oblique circle, you don't generally see this, but if you put the Earth's axis vertical, redraw your diagram, you have an oblique circle around the sun and an obvious cause of the seasons. Right, so Aristarchus calculated that the sun is about 6.5 times the size of the Earth. Actually said ratio 19 to 3, greater than 19 to 3, but less than 45 to 6. So these variations in his estimates are not on the accuracy of his measurements, or its calculation, but on the limitations of the geometry used to calculate the numbers. So that puts the sun massively larger than the Earth, about 270 times by volume. So it's assumed that he proposed the Earth goes round the sun instead of this. It then becomes easy to put the planets in order, rotating around the sun. There's no evidence that he actually did this, but it is quite obvious that he must have. And then it solves the problem of the retrograde motion of the planets. If you have been watching Mars for the last couple of months, it too is going in a retrograde motion. Instead of going through the stars in the background in the normal direction, it turned around and went backwards for a couple of months. This was well known. It's quite easy to observe. You have to be a bit patient. It only happens every couple of years. And rather annoying if you assume everything must go round in circles. And the universe is well designed on circles. So Aristarchus must have known this, and given the information that the Earth goes round the sun, the reason for this becomes obvious very quickly. And further, you can see that the retrograde motion of Jupiter is much less, and Jupiter is also moving across the sky slower, and Saturn even slower, and very little retrograde motion for Saturn. He then apparently went looking for parallax motion of the stars. So if we have the Earth moving to one side and the other of the Sun, a near star here, and from this side we see these stars in the background, and from this side we see these stars in the background. There's no evidence he did this, other than he came to the conclusion that the stars were very distant. So it seems almost certain that he did this. And he saw no parallax. It is not possible to see it with the naked eye, but it is the basis of all astronomy distance measurements more than 2,000 years later. So, what happened to the Greek establishment? Well, they didn't believe the sun could be so large. We'll come back to the size of the sun. He contradicted the assumptions of Aristotle, which is not a good idea. Athens thought it was the duty of the Greek to indict Aristarchus on a charge of impiety, which is a fairly serious charge. We'll come back to that. And it was actually from that, this quote about putting the motion of the half of the universe and supposing the heavens may remain at rest, and the oblique circle. So Athens lived in Greece. It's believed that Aristarchus moved to Greece. Whether he went to Alexandria or not, we don't know. Right, so what happens if you disagree with the philosophers? The classics people told me disagreed with what I say, but they said the Greeks sat around chatting up only in circles their philosophy, but when as long as you agreed with them, it seems, and if you step out of line, things mightn't be so good. Eratosthenes showed that the square root of 2 could not be written as the ratio of 2 integers. It must have been some dreadful geometrical construction. There's a high school proof of this these days, which he clearly didn't have, because there's various records of somebody else later determining the square root of 3. It was also irrational, and somebody else square root of 5, which if they had the current proof, those are trivial. So he showed that they couldn't write down the length of the right angle triangle, which is a bit embarrassing because it clearly does have a length. And of course they had no decimal notation, no positional notation, and so this was rather embarrassing. The stories vary on what happened to him. They went fishing, he discovered this at sea and was promptly thrown overboard. Another story goes that the gods, it may have been Pythagoras, were angry and drowned him. And yet another story says he was drowned for revealing the secrets of the dodecahedron, which is a 12-sided uniform solid. And so anyway, they're all consistent that he came to a wet end. Right, so summary of where we got. He calculated the size and distance of sun and moon simply by information he got by looking at what was happening. He must have worked for quite some time. He assumed the Earth rotates daily, the heavens are stationary. He knew that he placed the Earth in orbit around the sun with the other planets. He knew the axis of the Earth was offset, producing the seasons. He recognised the stars as very distant suns. He developed some mathematics for small angle triangles which he needed. And unfortunately the information on him is extremely limited, particularly on this last document. There's good reason to think he wrote quite a few documents. He seemed to spend his life as a mathematician, and writing 2 would seem to be a bit limited. Right, he was actually referred to by Copernicus in a draft of the I won't try and pronounce that. The document putting the Earth rotating around the Sun. However, that reference was removed from the final copies. So he was his work was known by Copernicus, and no doubt from Archimedes the sand rector. But he was first to use measurements of the solar system. His methods were correct, but were difficult to make accurately. So estimating the size of the moon from the shadow of the Earth as, well, it's 2 times. Somebody else came up with it later with 2.5. Not all that accurate. Distance to the moon was probably correct if you take a 50th of a zodiac. He recognised the Sun was large, but it was actually about 16 times larger than he estimated. He estimated the difference between the half-moon orbit and the half-moon was 6 hours, which is about all you can tell. He actually, in his assumptions, he said less than 6 hours, but he then worked on 6 hours. It is actually 6 minutes. And even with a telescope, you can't get that accurate. And he correctly recognised that the stars were very distant suns. So he had things well in order. Unfortunately, people took no notice of him. His document is lost, although they occasionally find documents hidden somewhere, so there is, I'm told, a possibility that it may turn up yet. Right, some references. There's a very good book by Thomas Heath, which covers 22 other Greek philosophers before it gets to Aristarchus. A book by Gomez, which is a bit junk, and goes into a lot of assumptions of what you might know. Wikipedia has some things on it, generally not too much. Right, and here we have the Earth and Moon actual sizes. Putting the Sun in is a bit difficult, but here we are. So, and that is here's the Earth, here's the Moon at full distance. So the Sun was more than 3 times the diameter of the Sun is more than 3 times the distance to the Moon. And you can see the Earth and Moon are quite small compared with the Sun. And if you're not convinced the Earth is small, here we are, view from Cassini, one of NASA's most successful ventures. Next year or the year after, it's going to drop about 15% of the world's plutonium-238 into Saturn. And yes, you can see the Earth in the background there, but it depends on what resolution you've got on the projector. You probably can't see it, so we have, there it is. So there's the Earth there, just a couple of pixels. Unfortunately in that, it's a little bit off-sided. The Moon is actually behind the Earth. Later, NASA took some more fraudulent pictures where they used the high-resolution camera to get pictures of the Moon and Earth. This is in the shadow of Saturn. So you can and then put it together in a composite picture. This one is actually a composite picture of frames across, I think there's about 12 frames in that picture. Right, so that's about what is known about Aristarchus.
Thank you.